continuation with the previous video. Here you can see through. So if you compact the soil sample on the dry side, we can see through soil particles have been more in dispersed structure, whereas in case of flocculent structure it will be there. So we can enhance more strength here when compared with the other side of the downstream. Here we can ensure flocculent structure has been there. Here it has been disturbed structure has been there. So higher the water content or the higher the compact effort will give you more dispersed fabrics. So once this has been done, we can see through another set of important thing. If you do different types of compact efforts for the different same soil sample, we can get back different curves like this. So first curve, second curve, third curve, and fourth curve. If you join all the peak points or this curves, we call it as line of optimum. So different compact efforts have been kept, and finally if we are going to join all this line curves with a simple line, so that line indicates that optimum values of line of optimum. And next in our video we'll go back to the field compaction. In laboratory we have seen how compaction is been done. Usually compaction is been done in laboratory by ramming, and whereas in case of field we cannot do that much compaction, or by the help of a rammer we can't do. So we require large scale of rollers. So different types of rollers will be there. In case of first one is smooth wheeled roller, second one is vibrator roller, third one is pneumatic tire roller, and fourth one is sheave foot roller. So each one will be having a different application. You can see through first we will go with a smooth wheeled roller. So this will be a drum will be there. This will be passing on top of a soil layer 1. So layer has been going to cut compacted. Usually this can be compacted up to 20 to 30 centimeter depth or thickness. So usually this can be placed on top of a shallow lifts or shallow layers. If you want to compact, this field roller is being used to compact the surface. Later we'll go with the vibrating plates. So this vibrating in compaction is been used for confined areas where we cannot take our roller. So here this small amount of vibrating plate will be used in a very small area with a compaction can be done. So like this. So if a traffic has been passing there, here it is required to compact the surface. We can't stop the traffic to pass through, and automatically we can take a compaction also will be carried out though the traffic intensity is being passing. So this is one best example we can see through. Or any confined areas where we can't bring out our compaction rollers, so this method can be adopted. So later once we thorough with this field compaction of vibrating plates, we will go with a sheep foot roller. So this sheep foot roller is been used for the clay deposits. So if like this been effective in our clay samples, so this projections are called as sheep foots. So they are going to look like as a sheep foots. So this will be passed. Once this will be passed, the soil undergoes a compaction phenomenon. This is another example of compaction, that is impact roller. So this impact roller, once it has been passed or rolled, so intensity of roll will be done. So this will be compacted for runways. Usually the compaction depth will be 2 to 3 meter depth. Here very high intensity of compaction can be done. So how to control this compaction systematically in a regular intervals, we have to check through compaction specifications. So one test have to be performed for 1000 meter cube of the compacted soil, and whereas the minimum density has been arranged or not, we need to check through. And in once we have done through the experimentation of compaction, we need to check through with either a nuclear density method or sand cone method to obtain the field densities. So with this I'll stop another our compaction test, our compaction chapter. Later in the different chapter we'll discuss about different things. Okay, thank you.